find each of the following limits if it exists. So we got 3 problems here. Okay, and let me recall about exponential function when x goes to infinity. So let's look at the graph of e to the negative x. Okay, I'm looking at the graph of e to the negative x. So this will be, this is the graph. So if we have limit of this graph e to the negative x, when x goes to infinity here, when x goes to infinity so big, this curve is gonna come closer to this line, which is 0 level. So this one is like e to the negative infinity. We don't write this, but in calculus sense we know it's just the limit. This is very, very big, e raised to negative, very, very big. Okay, and then that would be very close to this line, so 0. So we'll get this here. Okay, same situation. If we simply directly plug in here, it's gonna be e to the infinity minus infinity squared. Very big square is still big, infinity. But infinity minus infinity is indeterminate. Okay, we cannot determine. So this does not work. I mean, we cannot directly plug in here and find the value. But what you can do here is, let's factor x from the top. Okay, this limit is same as e raised to x minus x squared. We can factor x out. That leaves 1, because x is out, minus x. Now let's plug in here. Okay, e to the infinity times 1 minus infinity. So 1 minus very, very, very big is still big. 1 does not even count. So minus infinity. And that is e raised to infinity times infinity, very big times very big, still big, even bigger, but we just write negative infinity, very big. And look at this limit, e to the negative infinity is in fact 0. Okay, so if we graph, I mean, we can check the answer pretty much. If we graph this curve in our calculator, it's going to be something like this one. Okay, and when x goes to infinity, x is very, very big, this curve is going to come closer to x-axis. So y value is 0. So this limit is 0. Let's work on this one. So in this case, we need to get the help of graph. Okay, 1 over x minus 2. If we graph this one, 1, 2, this is 2. Okay, and then if we graph 1 over x minus 2 in our calculator, okay, it's gonna go downward. Okay, it's going to go upward, something like this one. Now, in this question, x is being closer to 2 from left. Okay, x going to 2 from left means here x is approaching to 2 from left side. Means from here, when x is very, very close to 2 from left side, the value is gonna fall. I mean, this is gonna go down without any limit, so it's going to be infinity, but very, very small, negative infinity. Okay, that's from the graph. Now we can write that in terms of notations here. Okay, so we can write in this way. This limit is same as limit x going to 2 from left side, that is 1 over, let me plug in. Okay, so we don't use this limit because after we plug in, we don't have to copy this anymore. 1 over 2 negative, okay? It's pretty close to 2, but less than 2, minus 2. And this is going to be very, very close to 0, but this will be kind of from left side 0. And 1 over 0 is only undefined, but this is not 0, okay? Very close to 0, but smaller. very, very small. And 1 over very, very small means this fraction will be very large. And we denote that by infinity, but there is a negative sign because very close to 0, so negative infinity. In fact, you don't have to even show this, or if you just refer to this graph, okay, and that's it. In fact, when we have negative infinity or infinity, the limit does not exist. I mean, there is no bound. Here we need to do the same thing. Graph this function, 1 over x minus 1. 1 is the same thing like previous. Okay, from left it's going to go to negative infinity. From right it's going to go up. So x going to 1, there is no direction, means we need to consider both sides. So here limit x going to 1 from left side of x minus 1. Okay, left means less than 1, very close to 1 but less than 1. We know that's the negative infinity. But if we approach 1 from right side, okay, from right side is 1 is going to go positive infinity. Okay, obviously they are not same. The limit does not exist. Does not exist.